Hello, in this video we will be looking at some videos of the three agents described in the experiments in our thesis, driving around in the CARLA driving simulator. However, first we will give a quick introduction of each of the models before moving on to the videos. All three models are based on the Learning to Drive from a World on Rails paper, which is described in more detail in our thesis. However, the biggest differences between these models is what happens around the last step of this algorithm, which we will refer to as the visuomotor training step. For the first model, VOR-R, we tried to recreate the original World on Rails model, using only a limited dataset of approximately 100,000 data frames. In this visuomotor training step, images are first passed through a ResNet34 visual backbone before the results of this module is passed on to a semantic segmentation head and an action head. The network then trains on both the task of action prediction and semantic segmentation. For the last two models, VOR-EF and VOR-EU, we introduce a new autoencoder training step performed prior to the visuomotor training step. In this training step, we train a ResNet34 encoder on both semantic segmentation and image reconstruction, using a highly relevant dataset containing images and semantic segmentations from the CARLA simulator. For more information regarding this dataset, please see our thesis. We use this trained visual encoder in two different visuomotor training processes. VOR-EF, where the encoder has frozen weights and only trains on action prediction with an additional interpretation head, and VOR-EU, where the encoder does not have frozen weights and trains on both semantic segmentation and action prediction. Moving on to the videos. During the presentations, videos will look similar to this. The agent's current speed is displayed here. The agent's current actions in terms of steering angle, throttle, and brake are displayed here. The current high-level command being given to the agent is displayed here. In addition, the telephoto camera view on the right is not being fed to the agent, meaning that the agent only sees the wide image displayed on the left. Now, let's look at some videos of the VOR-R model. In this clip, we see the agent handling traffic light states well under difficult lighting conditions and also performing a smooth left turn. In this clip, we again see the model handling traffic light states well in difficult lighting conditions. In this clip, we see the agent handling a rainy environment, both stopping for traffic and pedestrians, as well as handling turns well. In this clip, we see the agent fail to understand the traffic light state in an intersection, which ultimately makes it end up stuck in the intersection. Moving on, let's look at some videos with the VOR-EF model. In this clip, we see the agent run a red light and also perform some wobbly turns. In this clip, we see the agent running a red light, which almost makes it collide with an oncoming vehicle. In this clip, we see the agent ending up stuck in front of a puddle on the road. In this clip, we see the agent handling traffic light states, also stopping for vehicles and pedestrians. In this clip, we see the agent unable to interpret a traffic light, ending up stuck at the intersection. Lastly, let's look at some videos with the Vår EU model. In this clip, we see the agent handle traffic light states and other vehicles in difficult lighting conditions. In this clip, we see the agent also getting stuck at an intersection, unable to interpret the traffic light state. In this clip, we see the agent showing good vehicle collision avoidance. In this clip, we see the agent stop for pedestrians mid-turn.